Introduction. When the ideas of probability are applied to market a product, there are occasions when you need to calculate conditional probabilities other than those already known. For example, if the product purchased in a city is rated at 100%, what is the probability that the next city will also purchase on a high scale? You might need to know the probability of getting a product outcome ranging from 10% to 90%. There comes Bayes' theorem and total probability. In study sessions 2, our discussion centered on conditional probability and independence of occurrence of events. In this study session, we proceed further by building on the concepts through the concepts of Bayes' theorem and total probability. Learning outcomes for study section 3. At the end of these study sessions, you should be able to explain the concepts of Bayes' theorem and total probability. Bayes' theorem. Given that P of A over B is equal to P of A intersection B over P of B, equation 1, P of B over A is equal to P of B intersection A over P of A, equation 2. This implies that P of A intersection B is equal to P of B intersection A is equal to P of B over A, P of A, equation 3. Therefore, P of A over B is equal to P of B over A, P of A over P of B, equation 4. Equation 4 is known as Bayes' theorem, total probability. But P of B is equal to P of B intersection A plus P of B intersection A prime. From P of B minus P of B intersection A is equal to P of B intersection A prime is equal to P of B over A, P of A plus P of B over A prime, P of A prime. Generally, P of B is equal to summation P of B intersection AI at n I is equal to 1 is equal to summation n I is equal to 1 P of B over AI, P of AI, equation 5. Equation 5 is the total probability. Therefore, Bayes' rule can be written as equation 6. Example 1. The contents of 3 identical baskets, BI, I is equal to 1, 2, 3, are B1, such that 4 apples and 1 orange, B2, 1 apple and 4 oranges, B3, 2 apples and 3 oranges. A basket is selected at random and from it a fruit is picked. The fruit picked turns out to be an apple on inspection. What is the probability that it comes from the first basket? Solution. Let E be the event of picking an apple. Using the table below, the required probability is equal to, that is equal to 4 over 7. Example 2. In a certain town, there are only 2 brands of hamburgers available, brand A and brand B. It is known that people who eat brand A hamburger have a 30% probability of suffering stomach pain, and those who eat brand B hamburger have a 25% probability of suffering stomach pain. Twice as many people eat brand B compared to brand A hamburgers. However, no one eats both varieties. Supposing one day you meet someone suffering from stomach pain who has just eaten a hamburger, what is the probability that they have eaten brand A and what is the probability that they have eaten brand B? Solution. Let S denote people who have just eaten a hamburger. Let A denote people who have eaten brand A hamburger. Let B denote people who have eaten brand B hamburger. Let C denote people who have suffering stomach pains. We are given that P of A is equal to 1 over 3, P of B is equal to 2 over 3, P of C over A is equal to 0.3, P of C over B is equal to 0.25, S is equal to A union B. As those who have stomach pain have either eaten brand A or B, then A intersection B is equal to empty set. P of C is equal to 8 over 30. Then P of A over C is equal to 3 over 8. And P of B over C is equal to 5 over 8. So, if someone has stomach pain, the probability that they have eaten brand A hamburger is 3 over 8, and the probability that they have eaten brand B is 5 over 8. Summary of Studies Section 5. In these study sessions, you have been able to 1. Understand how to explain, define, and prove the twin concepts of Bayes' theorem and total probability. 2. Given any two events A and B in a sample space S, Bayes' theorem is defined as P of A over B is equal to. This is the end of Studies Section 3. Thanks for listening.